So hello viewers and welcome back to another video networking. So in today's video we are going to talk about a very interesting topic in networking, which is the most I don't know if you've heard of this question or if you're aware about this question or not, but since the IPv4 the size of the IPv4 address is like 32 bits and each device will have its own IPv4 addresses, so it's obvious that we will at some point we should run out of IPv4 addresses because we have the population of the world is more than the total number of unique IPv4 addresses that are possible. So why we are not running out of IPv4 addresses and how we have made that possible? So in today's video we are going to talk about the concept of NAT and PAT. So without wasting much time, let's get started. So as usual, the content of the topic that we are going to cover will be the same as we have seen for so many videos. So the content will follow like this: introduction of the topic, then why we need NAT, what is NATing, why we need PAT, what is PATing. Then we will see the simulation in CPT and NS3 for both of the NATing concept and PATing concept. So let's start the session with the introduction. So we'll first of all see what are the limitations that we have, and for that we need a little bit of background. So for the introduction part we will cover these many concepts in very basic, while we will not deep dive into much of the concepts, the introduction concept that are here, but just we'll go through it. So we must need to understand what is IP address, MAC address, what is the difference between these two, and what is IPv4. So we'll start with the very basic concept, which is like OSI networking. So as you know that we have the concept of OSI, Open System Interconnect, and in networking we have 7 layers, and each layer will carry their own responsibilities. And out of those we have this network layer and data link layer. So these two layers are very important because the main responsibility of the data link layer is to provide hop-to-hop addressing, where the MAC address will fall, and the main responsibility of the networking layer or network layer is to provide end-to-end addressing, which is where IPv4 or IPv6, and nowadays there is a very you can say popular concept of IPv8 comes here. So what is MAC addressing? So basically MAC address is like 48 bits long, and we represent those bits of the MAC address in hexadecimal format. So we'll have something like this: A1, B1, C1, CD, CC1, something like this. And the equivalent binary representation for this is like this. This is like this. So out of this 48 bits, the 24 bits are vendor specific, which is called OUI, and the rest of the 24 bits are device specific. That means one vendor can have 2 to 24 unique network interface card possible. Now these are the network interface addresses that are assigned to your physical NIC or network interface card, or we can call it as a NIC. So there are different kinds of NIC available in the market, such as this wireless NIC, this is optical NIC, where you can see the transceiver over here, and this is like a you can say electrical or Ethernet cable. You can plug Ethernet cable over here. So this is like a normal NIC that you might see in your computer or CPUs. So that is all about MAC address, and I hope now you know the relation between NIC and physical address, and or you can also call it as MAC address. Now followed by the concept of IP address. Now this is main thing for you to understand. So IP address is like 32 bits long, and we represent IP address in this dotted decimal format, where each binary byte is represented in this decimal format. So that means each digit or each byte can be from 0 to 255, because one byte uh, will have 8 bits and all the bits are 0 and all the bits are 1, so that means 0 to 255. So that's why this is the way of representing the IPv4 addresses. Now if you calculate, if you ignore all the reserved IPv4 addresses and stuff like that, and then you have 32 bits in IP address, right? And each bit can have 0 or 1 in it, so that means 2 raised to 32 unique addresses are possible. That comes around something like this: 4.295 billion IPv4 addresses are possible. And as of now, the population of world is around 8.3 billion. So that means you can currently see the difference between the total number of IPv4 addresses are possible and the population of world. And nowadays, a single person will have their own individual devices. They have laptops, they have mobile phone, and each of these devices who are using internet, we must need or must have the IPv4 addresses, some kind of addressing, logical addressing. Physical addresses we all will have, because all the devices will have NICs, so that is not the much of a worry about us. But main thing that you need to understand over here is this problem, where you have only 4.295 billion addresses possible, whereas the population of world is around 8.3 billion. So that is clearly the problem that we can see, right? And apart from that, there are certain reserved IPv4 addresses for experimental purposes or for multicast. So those addresses we are not counting here. So those addresses actually we need to take out from all the possible IPv4 addresses. But here we are assuming that we don't reserve any IPv4 addresses. So how we are making it possible? Let's see that. So to change this, to overcome this, we have done so many research, and people have come up with the alternate protocols like IPv6 and IPv8. IPv6 have like 128 bits, and which is like sufficient enough to assign each device an unique IP addresses, and that is like currently we are using, but that is like dual stack. Our legacy softwares or servers, they have IPv4 addresses, they are not moved yet to IPv6, but most of the devices on internet nowadays will have IPv6 addresses. But that is some way you can say a dual stack operation mode, so the devices will fall back to IPv4 when the IPv6 addresses are not available, stuff like that. And nowadays the concept of IPv8 is also very popular. If you have seen my previous videos, I have talked about IPv8. So IPv8 is also, the draft for IPv8 is also submitted, and which is like very promising. So we'll see about that. But yeah, the technologies to overcome the solutions are there. Instead of IPv4, we have stuff like IPv6 and 8, which are very promising, but they are not that much adopted. What technology we are using with IPv4 actually? So let's see about that. The solution that we have adapted is like NAT and PAT. So the concept of public addresses and private addresses, and these two concepts, the network address translation and the port address translation, these two are very popular, or they have been there where when IPv6 was not there. So these two technologies, or these two things, these two concepts in networking was very popular, and they have given the solution. So let's look at the NAT first, and then we'll see PAT. So what are they and how they provide the solution to the problem? So let's see that. And before that, we actually need to understand these public addresses and private addresses. So public addresses are like IPv4 addresses, those are routable on the internet. So actually you need to pay to get the public IP addresses to actually use that IP address over the internet. And private IP addresses are like, they are not routed on the internet by any of the devices, by any of the intermediate devices, and you can say we don't have to pay any fees to use those private IP addresses. So let's say if you are making a lab inside your home, then you can use private IP addresses. But if you want your lab to access the internet, then you must have at least one uh, public IP address to your entire lab, and then you can use the concept of NAT and PAT to translate your IP addresses, all the private IP addresses, to your public IP addresses. So let's see that how to use NAT and PAT. So first of all, let's see what is NAT. So NAT stands for network address translation, as I said. Now NAT is a concept of translating your private IP addresses into public IP addresses. So here we assume that we have infinite money. Let's assume that you have billions, millions of dollars, and you are ready to pay whatever amount that you will be charged to use the public IP addresses, right? So let's say here is a router which is hosted by your home, like which is inside your home. Now you will use private addresses to connect your devices to your router, and then this router will do some kind of magic. So when you send traffic to your router, what your router will do, your router will translate the private IP address which is assigned to your devices. So something like this 192.168.10.2 will be translated to something like this. This is like public IP address which is translated for this 10.2 local local IP, or you can say private IP. So that's how this is like simple process of translating your what you can say private address to public address, and this database is like maintained inside your router. So whenever there is any traffic from this IP 10.2, it will get translated to 27.28.192.1.168. So this is like public IP address that is you are paying to use. So something like this. So this is simple concept where you can simply translate your you can say private IP address into public IP address, and that's how whenever there is packet coming to this private IP address, it will public address, it will come to your router, and then your router will translate back that IP address to local private IP address, and then the packet will be sent to your device. So that's how the concept of netting is work. Netting works, and that is a simple way of solving the problem. But here there are some catch. So what are the catches is like, how many, let's say the simple in simple term, you need to pay for this IP addresses to use this, because if you won't put that scenario, then anyone can reserve any number of public IP addresses for their usage. So that's why we will fall into the same loophole, where let's say you have n number of devices behind your private address, and you are using n public addresses to translate all of these devices and making it routable over the internet. So that is not the quite, you can say, feasible solution. So now to solve even this problem, we have the concept of PAT. So now let's see what is PAT. So this is our last theoretical topic which will solve the problem that was even caused by NAT. So now let's see what is PAT. So the PAT simply stands for port address translation. Now what we will do over here is same concept. We have private IP addresses assigned to our home devices by our router. Now wherever we want to you can say route our traffic over the internet, wherever these devices that are connected in your private addresses, they want to use the traffic, we will have one public address assigned to your router. So what your router will do is, your router will make this kind of database where your private IP address and the source port which is mapped to one single public address and the global port. So that means entire pair will be unique by these two parameters, which is public IP address with the global port. So this is something like pair of process that is running on your devices, with the private IP address. So that entire pair is mapped to your single public IP address with the process running on your router. So this is like simple way of translating your private IP addresses into single public IP address. So what here will happen is you will have just a single public address, and all of your traffic will route over the internet through that public IP address. But over here, your router will create processes, unique processes. So that means this port number you over here you see. So the traffic from this device, it is sourcing from port number 50, but on your router it will create another process, and for that the port number was 10. So whenever there will be a traffic, there will be a packet coming to your router where the destination port is 10 with this public IP address, it will get translated to this private IP address with the destination port 50. So that means this device can receive the traffic where it was intended to. So this is the concept of port address translation, and I hope these two concepts are very clear, and these concepts are very straightforward, where over here you have the mapping of private IP address and the port number. Over here in the netting you just have the straightforward mapping of private IP address and the public IP address. So that's the way of people solving IPv4 problem, where we still in today also we don't run out of the IP addresses. So yeah, that's it for today's video. I hope you have got the idea about NAT and PAT. In the upcoming videos we'll see the simulation in CPT. So yeah, till then, keep learning and keep exploring. Bye bye.